I have a second channel, Cube Comp MTDX. Everybody, this video I'm going to be testing out some 18650s I recently harvested from a couple of different laptop batteries. On the right are these Sanyo UR18650As. I was able to determine from what I looked up online that these are 2100 mAh cells, and these came from a 2012 Dell laptop battery. And what was interesting was I had found apparently these cells are they're rated to their minimum operating voltage is 2.5 volts, which normally for a cell like this will be 3 volts. The cell on the left, which we'll look at in a moment, their termination voltage is 3 volts. So that's one interesting thing to see. I'm not the biggest fan of Sanyo cells. They were a subject of numerous laptop battery recalls. Then again, the same could be said about some cells from Sony, which I have some Sony cells up here I've been using for a while. So the reason these have been recalled, or some of these have been recalled, at least some of the laptop batteries that the Sanyo cells were in were recalled because of getting hot during charging. The packs would get hot due to the cells getting hot. So I'm not exactly certain. So I looked these up on Dell's, looked up the pack on Dell's website and did not see any recall information on the pack. So I'm going to say these are probably okay. Their voltage is okay. I think there was like 3.4 volts. So before I start these off, I'm going to talk about the Panasonics on the left here. These Panasonics, these are Panasonic CGR18650CGs. These came out of a Toshiba pack. There's a good look at the cell. So both of these packs were 6-cell packs. Two of them, well, I should say, in each pack there were 2 cells that were holding a low voltage, so they were getting out of balance, and something was probably wrong with those 2 cells. So they're not being included in this test, because the rest of these are holding a good healthy voltage. Again, these were, I think, 3.4. These are holding like 3.5, and these packs have been sitting for quite some time. So what I'm going to do is I'm going to start out with the Sanyos. What I'll do is I'll charge them up to their full voltage, and then I'll actually, before I do that, I'm just going to do a quick test using this charger's quick test function, and it'll check for internal resistance. Now, I think that you actually get a better reading when these are fully charged, but I figured it wouldn't hurt to just go and test them right quick just to see what we're looking at for internal resistance values. Now, if the internal resistance is really high, we may not want to use them. So let's just see what we have here. I'd say these are pretty respectable numbers. I think below 150 is a general goal. So the internal resistance is not too bad. Now, in comparison, let me find some other cells here that I know have pretty high values. Let me go and pull these out real quick. And you may notice I've numbered them, that way I can better keep track of them. Track of which is which. So just for comparison, these LG Chem cells I've been running for, I think, about 3 or 4 years. These are LG DA S3 1865s. These are, I think, 2200 milliamp hour. rated cells. These came from a Toshiba pack. Let's pop these two in there just to show you, for example, what their internal resistance is. You can see this one is way high. This one is they're both quite high. But let me just try this again. Sometimes they don't get the best connection. So yeah, it looks like 300 milliohms is closer to what their actual internal resistance is. So yeah, the internal resistance on them is quite high. Now let's look at these Sony cells I have up here. Now these are still in regular use. I use these to power my weather case and porch cams over on CubeComp MDX to film thunderstorms and weather and stuff. So these see various operating temperatures. You can see these are getting a little high, but these cells, in particular these Sonys, are from 2003. I think that's pretty fantastic for cells that age. For cells that are 18 years old. They're still working. So anyways, that being said, let's go ahead and switch this over to charge. Man, my neighbor is really going crazy in their Tahoe. It's probably her boyfriend driving it. Alright, so we're going to charge these up. And we'll see what we get. Let me pull these back out. Now I know that that last one wasn't 0.9. It shouldn't be. There. 3.5. We'll charge these up at 1 amp. That's how I usually do them. Okay. So they're now charging, and what we'll do is just try to keep an eye on them. Check the temperature once in a while. Make sure they're not getting hot. If they're properly functioning, they should not get hot. At most, they might get a little warm. That's pretty typical, but they should not get hot. There they go again. So you may notice my charger is up higher now with this fan mod. I recommend you go check out my fan mod video if you have one of these Opus chargers. So I want to say it's the Opus BTC 3100, the BTC 3100 like I have. And there's also one that's sold under the Ambient Weather brand. I think it's a... I can't remember the model. It's something 3000. So if you have one of them chargers, this is definitely something I'd recommend doing if you have access to a 3D printer. So we'll again let these charge up and I'll give you an update. Okay, everybody. So the cells are getting close to the end of their charge. You can see we're all sitting above 4.1 volts. At or above 4.1, and these cells are exhibiting the classic issue that Sanyo cells tend to have. Once you get near the end of the charge cycle, they turn into little heaters. These two over here are not doing real bad. They're actually just barely warm, but 1 and 2, oh my gosh. For example, cell 4 is just 33 degrees Celsius. Cell number 3 is 39.5, but cell 2 and get a good angle on it. So we got about 44. And cell 1, 54. So as far as I'm concerned, cell 1 and cell 2 have already failed the test. I'll continue with cell 3 and cell 4. However, cell 1 and cell 2, they're done. I'm taking them off. I do not like cells that get hot in a charge cycle. That's typically not a very good sign. Yeah. Over 50 degrees C, especially when you get closer to 60 degrees Celsius, that's not a very good thing. And of course, this is just this thing measuring it, so it may not be exactly the most accurate. So yeah, cell 1 and cell 2 of the Sanyos are done. They're not going to be included. Cell 3 and cell 4, as long as they don't get too hot, I'll continue with them. They're still doing okay. Again, 4.1 to 4.13 is what they're sitting at now, and they're just a little warm. Now it does seem like cell 3 is heating up a little bit. So if these heat up like crazy, unfortunately I'm going to have to take them off the test. I might still discharge them and see what we get out of them, but yeah, considering these are getting hot, not a good sign. Okay guys, so cell 3 is heating up. Cell 4 is just barely warm, and it's really close to ending the charge cycle at 4.15. Cell 3 is at 4.10. Cell 4 is at 37. Cell 3 is at 50. So cell 3 is definitely heating up. In comparison, the two other cells I've got charging over here, I just started them a few minutes ago. They're at 30. So now, of course, if I cycle through and look at the details, of course these are getting less current now because they're getting close to the end of their charge cycle. That's how a constant current, constant voltage cycle works. Woo, that cell there is getting really hot. Maybe this be the way I felt it. Yeah, guys, that's not good. I'm gonna go ahead and take cell 3 off the charge. This right here, guys, I believe is why a lot of laptop battery calls got issued. Because it sounded like they were all ones that had the Sanyo cells in them. I had a few that I've already gotten rid of some time back. Now this pack, as I mentioned, was not on the recall list, but that doesn't mean it didn't exhibit the same problem. Maybe this wasn't determined as of yet. So yeah, these as mentioned, the packs I had, there were several from HP and I think a couple from Toshiba. That you can, if you looked at the pack label, you see Sanyo mentioned as a cell manufacturer. This I tell you, it's hard to hold. It's hard to hold this thing. It's so hot. Yeah, these things they got recalled because they were overheating when charging and sometimes catching fire. So that's why, of course, they took action and recalled the things, because these cells, it's sad, because I mean, I'm not sure what that was, but yeah, that's the thing, is it seemed like these would have otherwise been good cells, except for the fact that they get hot during the end of a charge cycle. And you can actually Google this information online about Sanyo cells heating up near the end of their charge cycle. So they were fine earlier when they were getting an amp pushed to them. But yeah, it's crazy. So we're gonna let cell 4 finish, provided it doesn't heat up, and we'll test it out. Maybe I'll use it. Maybe I'll add this cell to my flashlight collection. I mean, that's the only single cell application I have is my flashlight. So if this cell checks out, I'll probably include it with my flashlight collection. Okay, everybody. So I want to go ahead and show you something. So as you may recall, earlier I took out cells 1 and 2 and put in these 2 cells here I needed to charge up. They were sitting at, I want to say 3.6 volts, something like that. And that was a little over half an hour ago. And you can see they are nearing the end of the charge cycle. Matter of fact, they've already caught up with this cell here. So this cell here is also exhibiting that same problem. It's now heating up. So here is essentially what's happening. You can see how these cells, they've only received about 500 milliamp hours, yet this one's received 1700 milliamp hours. So what's happening is essentially with this cell here, a lot of the energy that your charger is putting into it, in this case, this charger is put in 1700 milliamp hours, a good chunk of that has been wasted as heat. So a lot of the energy that was put into this cell was not stored in the cell, but rather wasted as heat. This cell is now at 44 degrees C, whereas these over here are just sitting at 31.5 roughly. So, you know, these cells here, they're not holding a whole bunch of a charge anymore. The capacity, excuse me, guys, the capacity is these are only holding like 1300 to 1500 milliamp hours, and they were originally just 1900 milliamp hour cells, which is already pretty low for 18650s, but nonetheless, these are not holding near as much, but they're still working fine. They don't get hot when you charge them. Whereas the Sanyo, it's makes a nice hand warmer over here. You could about heat your house with it probably, if you combine them all together. The heat that's going, the energy that the charger is putting into the cell is not really charging the cell. It's just going out as heat. And that's not a good thing. That's a sign of problems with the cell. So I believe we've reached a point where the cell is not going to really accept any more charge. You may recall I did a video a while back of some cells that I harvested from an 8-cell replacement pack from my red HP laptop that had quit working after just a year, and they were horrible quality cells. They were getting extremely hot under a charge, and it got to the point where I don't think they ever reached 4.2 volts. They sat at a certain amount. That's not quite, of course, not quite full charge, and they were just taking a charge, but instead of taking and accepting a charge, it was just rejecting it as heat. And that's what this Sanyo cell is doing right here. So, you see, we're at 4.6, but we're still 4.16. Excuse me. We've been sitting there, I think, for quite a while now, and it's just, you can see these cells have already surpassed this one. They're charging right up just fine. Whereas the Sanyo is not. I could probably sit here and leave this, and the Sanyo will probably just keep eating power, but not charging up. So I'm going to pull this off of here, because I think it's pretty safe to say it's done. So unfortunately, the Sanyos, none of the Sanyos I'll be keeping because of the heating issue. The fact that they're heating up and they're still hot, guys. They're still pretty warm. That leads me to believe that these cells they need to be recycled. They got issues. So, for example, let's see what the voltage is on these right now. 3.89 and 3.97. I'm not going to charge them up any further because they're going to do the same thing that cell 4 has been doing. That's essentially what they've been doing. Is the heat that's been coming out of them is just wasted power, and that's not what you want in any battery like this. Okay, so those other two cells just finished charging. Now I'm going to go ahead and discharge these 4 Sanyos. So they're not all sitting at full charge, so we're not going to get the full capacity that we would otherwise get if they were sitting at 4.2 volts. But the thing is, some of them, maybe all of them, probably wouldn't reach 4.2 volts. They would just sit there and keep taking a charge from the charger and expelling it as heat instead of, like, you know, doing what a battery is supposed to do, storing the charge. So I'm going to pop these in there. You can see we're kind of all over the place between 3.86 to 4.04 roughly. Discharge them at 1 amp and we'll see how it goes. And just have to keep an eye on the temperature, see if they get hot while discharging. Okay, so they just finished discharging. Now, of course, as a reminder, they started out not quite at 4.2 volts. So let's see what we got here. Now, this one here just finished, so it's still recovering. Yeah, not very impressive. Yeah, so I'd say all 4 of these cells, it's time for them to be recycled. They get hot when being charged. They don't have a lot of capacity left in them. They're done. So we'll move on to the Panasonics next. Okay, so now I'm going to try out the Panasonic cells. So first thing I'm going to do, since I don't think I did it last time with these yet, I'm going to do the quick test. So let's do a quick little check of the internal resistance. Try to line these up by numerical order. And just for safe measure, let me try it again. So it looks like we're getting between 100 and 150, which is alright. Definitely not as bad as some cells I've got, so. The thing is with this charger, if there's any, if the connection is not really good with the cells, the numbers will be kind of all over the place. Okay, so now I'm going to do is I'm going to charge these up. You see they're all sitting at 3.9 volts. Yeah, excuse me, 3.49 volts to 3.5 volts. And we're going to charge them at 1 amp. And we'll see how it does. Hopefully these won't get hot like the Sanyos did. I have a feeling they probably won't. So again, let them charge up and I'll update you with the results. Okay everybody, so while I thought I would have zero problems with these Panasonics, that's not exactly the case. We're getting close to the end of the charge cycle and we've got some heaters. Mainly the ones on the left, especially number 1. We'll start from cell 4 and work our way over. 43 degrees C, closer to 44 on cell 4. About the same for cell 3. Cell 2 is at 50, closer to 51. Cell number 1 is at 53. So, not a very good sign. That means these things are wasting power in the charge cycle. So, that being said, I think I'm going to go ahead and pull these off. Particularly cell 1 and cell 2 right now because they're getting super hot. Now you think about it, if you look at the label, it says do not heat above 212 degrees Fahrenheit, which is the equivalent of 100 degrees Celsius. But once you start getting over 50 degrees Celsius in a charge cycle, I'd say that's likely an indicator of a problem. So some of y'all may say that's sometimes normal. Well, put it this way, I have a whole collection of Sony 2200 mAh cells, a collection of Panasonic 3400 mAh cells. I've got these Chinese generic 1900 mAh cells and some LG Chem 2200 mAh cells, and they do not get hot in charge. They barely get warm actually. So this tells me these cells may have seen some neglect. That means they're not exactly in the best of condition. And these are, as I mentioned, these are starting to warm up too. They're not quite as hot, but they're sitting at 42 to 43 degrees Celsius each. So, looks like I might not be finished cracking open laptop batteries. Because honestly, I prefer to have cells that don't get hot during charge. Cells that I'm comfortable, like for example, if I'm busy doing something, like in the house somewhere, I feel safe putting these on the charge. Or heck, if it's late and I want to charge them up for the morning, I can charge them overnight and feel safe doing it. My other cells I feel safe doing it with. These, however, not so much. Now I should mention I don't usually charge cells overnight, but sometimes if I'm in a pinch I will. But these would be ones that I would not do that with for sure. Yeah, that makes me uncomfortable when they get hot during a charge cycle. Typically they shouldn't do that. Okay, so now cells 3 and 4 have caught up with cells 1 and 2 as far as temperature goes. Pretty much sitting at almost 50 degrees Celsius on cell 3 and 54 just about on cell 4. So yeah, we're going to go and pull these off. Stop the charge. Let them cool down for a moment, and I'm going to actually discharge them. Okay, so these cells have cooled down some. They're not quite as hot as they were earlier. Once we get them on the charger, they'll cool down even more because the fan will pull air through these vents. That'll help cool them down some more. Yeah, this fan mod on this charger has been working fantastic, especially in discharge applications where it really actually gets hot. The fan does a great job at keeping the charger and cells cool while also not making a bunch of noise. Let's go ahead and insert these. Keep them in numerical order. Their voltages haven't really dropped that much. It's a shame that they're it's a shame that they seem to have an issue with getting hot. So we'll just charge them at 1 amp and see what we get from them. But considering the fact they get hot during charging, that's enough for me to fail them. So they'll be most likely getting recycled. Okay, so the discharge just completed, and these are our final numbers. Yeah, not very good. If I toggle through here, you'll see the times it took. These only took about a half hour, and these took around an hour. And of course, these were taken off before these two, so. They're now sitting at, these are sitting at 3.68 and 3.65, 3.55 and 3.6. What's interesting is when I pulled them from the laptop battery, they were holding a lower voltage, so it makes me wonder how low they've been taken. Because I believe this charger takes them down to like 2.9 or so before it stops discharging. Something like that. So yeah, pretty safe to say these cells, they'll be getting recycled. Yeah, can't have cells getting hot when charging. That's just a fact. So anyways, hope y'all enjoyed this video. Thanks for watching. Well everybody, that's it for this video, but don't forget there's a lot more interesting stuff on the channel to check out. Also, if this is your first time visiting this channel, feel free to subscribe to keep your channel, and also don't forget to tick the bell so that way you'll get notified of new video posts. If you like this video, please give it a thumbs up, but if you really didn't like it, there is the alternative option available as well. Also, feel free to check out my second channel, CubeComp MTDX. There you'll find videos about bicycling, weather, elevator tours, and all sorts of other neat, interesting stuff. I hope you guys enjoyed this video. Feel free to come back, and thank you for your support.